The Intel 8th generation Core i3, Core i5, Core i7, and the new Z370 chipset to go with it. This is sort of the news at the time that I'm making this video. These are the new CPUs from Intel. And this is the MSI Z370 Godlike Gaming motherboard to go with it. This is quite possibly the highest end Z370 motherboard that I've ever seen. Can you tell? I mean, look at this box. This is a serious box. You can tell by the thickness of the box, the weight of the box. I mean, good Lord. 10 USB 3 ports on the back, two 3.1 Gen 2 10 gigabit per second ports. It's crazy. This motherboard has 3 built-in wired NICs and 1 wireless NIC. Why on earth do you need 3 built-in wired NICs? Well, if you want to prioritize your gaming network traffic for the entire network at your house or wherever you've got your machine hooked up, then you would route all of the internet traffic through your computer. And this comes with killer software to let you do just that. Your computer can act as a router. And so if somebody is going nuts on your network, trying to download stuff or run a torrent or whatever, your machine can act as gatekeeper and prevent that from happening. And so that's why it's got 3 wired interfaces. For us, we just want to use it for file transfers. So we hooked all 3 of them up to the local network, and our file server is of course 10 gigabit. So we were able to transfer files back and forth at the theoretical maximum of 3 gigabit connections. It's about 330, 340 megabytes per second. So they are killer NICs, all 3 of them, but the killer NICs live up to the speed. I even tried substituting in some Intel adapters, and that made everything actually slower, which was kind of interesting. And then of course we have the killer Wi-Fi, which is an 866 2x2 solution with Bluetooth 4.2 for connectivity there. Let's take a look at our full motherboard I/O. Just really quickly, let's run through the connections. The top edge of our motherboard, we've got our vertical M.2 slot, which is for our Wi-Fi solution that is pre-installed. We've got a CPU power connector, both at 8-pin and a 4-pin, because yeah, you need to be able to dump 600 watts into the CPU. Now in our testing, we were able to hit 5.1 gigahertz with only a modest voltage bump, like 1.3. But there is a huge amount of variability in Coffee Lake CPUs. Some CPUs will struggle to hit 5 gigahertz, even with 1.4 volts. Other CPUs will effortlessly hit 5 gigahertz at 1.3 volts. Your mileage may vary. I really wouldn't push past about 1.35 volts because you're going to dramatically shorten the lifetime of the CPU beyond that. The heat's also going to be a problem to manage. So then of course right next to our 4 DDR4 DIMM slots, we've got a 4-pin CPU fan connector, and just above that we've got 2 surface mount buttons. One of these you can hit and it'll take you directly into the UEFI. It'll take the system from an off state directly into the UEFI, which is useful if you're using fast boot or something like that. And the other one will retry. So with DDR4, sometimes when your system is off, there's a training process that needs to happen between the CPU and the RAM. And the first time you install memory, the training process will occur. And sometimes when the machine has been off or it's cold, the parameters that it learns from that training process are a little different. So when you first turn on the machine, it may not post, especially with an extreme overclock. So the RT button will give you a retry where it'll just retry without clearing the CMOS or doing anything like that. It's really useful for extreme overclockers if you're gonna do liquid nitrogen. If you've got a custom loop water cooler and you've got an extreme overclock, you know, you're pushing Coffee Lake to 5.2, 5.3, 5.4 gigahertz. It's a useful feature. Then just on the other side of the DIMMs, we've got our diagnostic code readout, which when the system is booted will tell you the temperature in Celsius of your CPU, which is a nice handy feature. We've got the water pump header, which supports high current water pumps. Things like the Fractal S24 and S36, which get their power from the motherboard header, you can plug in there and just not even worry about not having enough power on the motherboard, because there's definitely enough power coming off of the header. Then we've got 2 more 4-pin fan headers right next to that, and our 24-pin ATX power connector. There's also a couple of buttons and a knob here, a power and a reset button of course, but then this is our OC Game Boost knob. Now in our live demonstration we turned it up to 10 because it doesn't quite go up to 11 on this CPU. And with the 10 preset, that's a 5.1 gigahertz overclock with this particular i7 CPU. Basically there's a table of presets based on MSI's internal testing, and you know, going through hundreds of CPUs, you can use the Game Boost like settings for your CPU. So odds are your CPU is going to be close to one of those settings. Can you achieve better clocks and better temperatures by dialing it in manually? Yes, absolutely. But if you don't really want to do that, or you're scared of doing that, you could start at like a setting of 2 or 3, and if your system is stable for a while, maybe you could crank it up to like 3 or 4, and if your system is stable for a while, you could crank it up a little bit more. I would definitely suggest not starting with 10 or 11, definitely don't do that. Because if your system is not stable at like 4 and you crank it up to 11, that's going to be dumping a lot of voltage and things like that into your CPU. And if your CPU was already iffy to begin with, that might make it even more iffy. So, you know, definitely don't start much past like 4 and use your system for a while, see what kind of temperatures it produces. Do some different workloads, maybe render a video, something like that, because rendering a video is a completely different workload than gaming. We were gaming on the live stream at 5.1 gigahertz on a whole bunch of different games, and it was completely fine. But I have a feeling that running Prime 95 or encoding a video or something like that would be a little less stable. That's just the nature of overclocking. Just below our 24-pin CPU power connector, we've got the first of 4 analog external temperature inputs. Now, those are included in the box. You can put these temperature sensors on anything. You can put them on your video card. You can just tape them in place. Hard drives around your case. Whatever you want to do in terms of gathering temperature from external sources other than your motherboard. So there's 4 headers. This is the first one. And you can plug those in anywhere you want, and it'll read the temperature from the other end of the cable. It's that simple. Then below that, we've got 2 more 4-pin fan headers. Below that, we've got our USB 3.1 Gen 1 front panel connection. Then we've got our TPM header, and then we've got our USB 3.1 Gen 2 front panel header. So this will give you USB Type-C on your front panel with a 10 gigabit per second interface. Then we've got our 6 gigabit per second SATA ports. Those are all at a right angle. And then just below that, we've got our U.2. Now our U.2 shares bandwidth with our bottom M.2 slot. So if you've got 3 M.2s and a U.2, you'll have to use the add-in PCI Express card, which we'll talk more about in a minute. Just above the U.2 connector is a BIOS flash button. So if something else comes out that's compatible with the Z370 chipset and your machine is not posting, you're putting a new machine together, you can upgrade your BIOS without having a functional CPU. So this is a nice feature. You can use that button to initiate a BIOS flash. You'll have to read the instructions and read more into it, but that's what that button's for. At the bottom edge of the motherboard, we've got our front panel audio connection. That is, of course, based on the Realtek ALC 1220. Then we've got our first RGB header. This is just a standard 50/50 RGB header. Then we've got 2 more 4-pin fan headers and 2 more of the temperature sensor inputs that I was telling you about before. Right next to that is a switch. This motherboard has 2 BIOSes on it, an A BIOS and a B BIOS. And so if something goes horribly wrong, or you have a BIOS that's like experimental or overclocking or designed for liquid nitrogen, this will let you switch between the 2 BIOSes. And then right next to that, we've got a 3-pin dip switch. Now, because this motherboard has so much onboard connectivity, and because the PCI Express situation is a little weird on Coffee Lake, well, it's not a little weird, it's basically exactly the same as KB Lake and Skylake before it, there are 16 PCI Express lanes to the CPU, and then there's the DMI interface to the chipset. Now the chipset provides additional PCI Express connectivity, but all of that connectivity is aggregated through the DMI interface to the CPU, which is about equivalent of a PCI Express 3.0 by 4 interface. So in terms of like PCI Express I/O into the CPU, there's only about 20 lanes total, 16 plus 4, maximum bandwidth simultaneous. However, the chipset has more, PCI Express channels on it. It's just that the devices on it can't be running at full speed all at the same time. It kind of makes sense from a system design perspective that if you're plugging in a mouse or whatever, you don't want to give it PCI Express, like the full PCI Express bandwidth, because you're never going to be moving your mouse that fast. And if you are, you're probably on speed or some other type of narcotic. And well, I just don't even want to think about that. That's just not even something we talk about here on this channel. We don't put up with that stuff. So yeah. So this dip switch will actually disable devices in different slots, because some of the resources are still shared through the PCH. So this has got 3 onboard NICs and M.2 and U.2 and the bottom PCI Express slot. Well, depending on how you've got devices installed, some of those devices may step on each other. So like we installed an M.2 in the very bottom slot, but when we did that, it needs 4 PCI Express lanes. It will disable the 3rd gigabit network interface, and it will also disable the very bottom PCIe slot, because there's not enough PCI Express lanes even on the chipset to support all of those peripherals, because this motherboard is maxed out. So the dip switches will let you explicitly set which things are enabled and which things are disabled to toggle between devices, or if you're troubleshooting something, that'll give you another thing that you can use, another tool in your arsenal of troubleshooting. So it's handy that it's there. And then we've got our USB headers. We've got 3 USB 2.0 headers and another USB 3.1 Gen 1 5 gigabit per second front panel USB header. Now in the box is a USB hub, an internal USB hub. So if you've got a lot of internal USB peripherals, like we've got our Corsair all-in-one cooler here, which can plug into an internal USB header. Corsair power supplies can plug into an internal USB header. You may have a lot of those devices in this amazing, it's Godlike Gaming. You're building a Godlike Gaming system around this, right? I mean, you're not gonna cheap out and get like a cardboard box for a case. You're gonna go, hard line tubing, and you're gonna, right? I mean, that's what you gotta do with this kind of stuff. So yeah, that's what that connection is for, to the hub. And so everything you need for that is in the box, and you can run all your devices off that USB 2.0 hub and keep your wires nice and neat. So it's pretty neat. Then of course we've got our front panel connections and our LED rainbow strip. Now what is rainbow strip in their vernacular? Rainbow strip is a programmable LED strip where each LED on the LED strip is individually addressable, and so every LED on the strip can be a different color. You can do some pretty cool stuff with that. We've seen it's the new hotness this generation. So yeah, RGB, woo! And then just above our primary X16 slot, we've got 2 more 4-pin fan headers and a 6-pin PCI Express power input. Because think about it, if you're gonna run 4 graphics cards or 4 high current devices off this motherboard, each high current device in these by 16 slots can draw up to 75 watts of power. So the motherboard's gonna need some supplemental power if you're gonna have a ton of peripherals, so you use that. Now that is an optional connection, so if you're not gonna run 4 graphics cards or 4 high current devices, you don't need to plug that in. But if you are gonna run 4 graphics cards, then the motherboard's gonna need supplemental power because hey, 75 watts times 4, kind of a lot of power. So let's talk about PCI Express layouts on this motherboard. There's 4 by 16 slots. What's the block diagram look like? Where do these go? Well, if you're gonna run by 8 by 8, you'll wanna skip one of the by 16 slots so that you've got a little bit more room to breathe. If you're gonna run 3 graphics cards, well, SLI is out, NVIDIA is out. Crossfire would be an option, and it'll be by 16 by 4 by 4 directly into the CPU. Like say you've got a PCI Express 3.0 video capture card. 2 of those are typically PCI Express by 4. There's a couple that are by 2, 60 FPS. High bandwidth devices probably don't want that running through the chipset. You can run it by 8 by 4 by 4, which is actually a great situation. This is a great motherboard, even for like audio production. So I'm sure that, Godlike Gaming, they intended it for it to be gaming. The Coffee Lake platform, because it's such a high clock speed and relatively low latency, it's an even better platform than the i9 platform, the X299 platform, because it's such low latency. So in terms of like digital audio production, if you want, ultra low latency, this is the platform for you. And this motherboard might be the motherboard for you because you can run by 8 by 4 by 4. So you could run by 8 for your graphics card and then by 4 for 2 high-speed peripherals directly into the CPU, which is hard to find on non-workstation motherboards. And as of the time of this video, I'm not aware of any Z370 workstation-ish motherboards, but that PCI Express layout is great. So like we use Blackmagic capture cards, and so like the high performance, ones of those you need all you can get. This is an ideal layout for that kind of stuff, so works out pretty well. The bottom slot is by 4 into the chipset, always. So, and it shares bandwidth, as I said, with a lot of other stuff on the motherboard. So if you do end up using the bottom slot, you can't use the M.2, you can't use the U.2, and you lose one of your 3 built-in NICs, but it'll give you up to PCI Express by 4 connection. Now, if you're only using like PCI Express by 1, well, it's not gonna be that complicated. Now, in terms of other PCI Express connectivity, there is a PCI Express by 1 slot that is into the chipset as well. This motherboard has a total of 3 M.2, but also included in the box is a PCI Express by 8 adapter card, which will let you run 2 of your M.2s directly into the CPU, no bottleneck. Now the Intel RAID, if you do that, is a little squirrely. I'm not sure that works, but you can totally do software RAID or other stuff. If you're using Linux, you could just use MD. You don't need the Intel software RAID. MD is totally fine. Now let's also talk about the audio solution on this motherboard, because yes, it is based on the Realtek ALC 1220, but that's where the similarities with other motherboards kind of end. This motherboard has 2. One is designed for putting out the audio at the back on a 1/4-inch jack, and it also uses ESS Sabre audio DACs. The other ALC 1220 is driving all of the front panel audio and the rest of everything else. So this motherboard basically has dual onboard sound cards, one for the front panel audio, one for the rear audio. The ESS Sabre DACs are designed for delivering crisp, clean audio, 120 dB signal to noise ratio, isolated part of the PCB, all the fixins. Also up to 600 ohm headsets, auto sensing, auto control, that sort of thing. So you can really go nuts if you want a really high-end audio solution here. So it's pretty nice. In terms of other accessories in the box, this box comes with a ton of stuff. There's stickers, the manual, the driver installation CD, which by the way, the driver installation CD is a pretty nice suite. You get the killer software that I mentioned before. There's also a DPC, deferred procedure call latency tuner software, so that you can make sure that there's no problem with your deferred procedure call stuff, which is again important to the people that are doing professional audio. That's also available on some of the lower end boards from MSI too. So if this is like way overkill for your stuff, maybe check out the Carbon AC. It's got the DPC latency checker as well. There's also braided SATA cables. It's got a nice cloth finish. You got some matte black ones, and then you got some matte black ones with little red specks in them, which is pretty nice. The rear I/O shield also comes with some magnets for some different designs. You can go with plain silver, as I've done in our test build here, but there's also some other designs that are magnetic and will just magnetically sort of go on the back. So I imagine you could also probably 3D print another thing to go back there that'll just snap right onto the metal cover. So if that's not something MSI has thought of, they should get on that, because hey, 3D printing your own I/O backplate to really match everything in your case could be a thing. Also included in the box are just completely, utterly ridiculous antennas for your wireless solution. Would have been much better to just have a wired antenna solution where you can move the antenna around than these lobster claw chopstick things. But hey, gotta find something wrong with the motherboard, right? And if really, honestly, if the only thing that I can find wrong with this thing, other than its, extreme maximum overkill, I mean, this is like swatting flies with a Buick. I mean, this is completely nuts. Then yeah, I'm gonna complain about the lobster chopstick wireless antennas, because my goodness. The Carbon AC wireless antennas were fine. The ones on this, just go to the production line, just swap those around. It's all you gotta do. It's all you gotta do. Also included in the box is a rainbow RGB strip from Fantex. Yes, in the box you get a Fantex RGB LED strip. How crazy is that? It's not very long, but hey, you can get your, sort of wet your whistle. It's like crack. It's like, the first one's free, but you're gonna buy 17 more feet of these. It's gonna be great. Now in terms of Linux support, everything on this motherboard in Linux basically worked out of the box. I mean, pretty much. The network cards were detected, which is great, running kernel 4.14 on Ubuntu. Yeah, I'm doing some testing on Ubuntu. We'll get back to Fedora in a bit. The IOMMU groups were actually really good. So this actually might be a good machine for running something like Cubes, because each of the onboard NICs was in its own IOMMU group, which I was kind of surprised about. However, running 2 graphics cards, everything there was in IOMMU group 1. So even though I'm running by 8x8 for my graphics card setup, it's only running in one IOMMU group. Now you can kind of get around it a little bit. So like if you run a slower graphics card off of the chipset, then you can avoid having it in the same IOMMU group. It's just that if you want to run your graphics cards, both of them off of the CPU lanes, they're going to be in the same IOMMU group, which is unfortunate. If you can run one of your graphics cards by 4 off of the chipset, then your IOMMU grouping situation looks pretty good. But if you don't do that, if you want the graphics cards in a by 8x8 off of the CPU, they're both in group 1. You could use the ACS patch, but as we've seen with graphics cards, not very stable. Hopefully Intel will fix that. That's been universally true on every Z370 motherboard I've looked at. In the by 8x8 configuration, they're in the same IOMMU group. No, Khan! Star Trek II, The Wrath of Khan, it's like that. I'm trying to channel my inner Shatner. I don't know. These motherboard reviews are so long, but there's so much information. I don't know. Other than that, the IOMMU groups look good. If you want to use the iGPU is also in its own group, which is handy. So you could use an add-in graphics card and the iGPU, and use the iGPU for the host. The add-in graphics card will be in its own group. That is an option. Just using 2 add-in graphics cards, not so much of an option. But it would be problematic, at least on all the motherboards I've looked at so far. Hopefully that'll change. As of right now, not so much. In terms of other support for Linux stuff, Linux kernel got some patches to deal with changes in the CPU. Turbo Boost 3.0 is still perhaps a bit sketchy. Doesn't really introduce any stability issues, but if it does, you can disable it in the BIOS, at least that I've found. Basically it works. You might not quite get turbos quite as high on Windows as Linux. Intel also leaves us up to the motherboard manufacturers a little bit. Some motherboards will turbo higher than others depending on the voltage profile, heat, and some other production. But as far as I can tell, this motherboard was doing what it's supposed to do in terms of turboing and Intel Turbo Boost and all the stuff that goes with that. But every motherboard is going to vary a little bit. Of course, out of the box, 3.7, but it'll turbo up to 4.7 on one core just on its own if everything's in an ideal scenario. So Linux support, MSI, good job. The Linux support on this motherboard is reasonable, and you will not have a terrible time if you try to get Linux to work on it. So that's nice. That said, I am using a bleeding edge kernel, so your mileage may vary with an older kernel. Good luck. You can always come to the forums. We'll try to sort you out. It's fine. It's fine. And I think with that, I think that's pretty much all there is to say about this motherboard. This motherboard is extreme maximum overkill. It is crazy. It is really nice to see that the voltage regulation, the voltage delivery circuitry has been upgraded by MSI for the 6-core design. That's it's one of the reasons Intel cited for saying that, hey, this 6-core chip is not going to be backward compatible with our Z370 chipset. MSI has done a nice job putting this motherboard together. It is extreme maximum overkill. If you want the absolute maximum frame rates in games, and you're going to buy the highest end video cards and the highest end components you can get, then this motherboard is worth a look. If you're doing production and things that benefit from having more cores, you could put the money toward something else that has more cores. I mean, this platform is going to top out at 6 cores. Conceivably in the future, Intel might release an 8-core part that has similar power requirements that would fit into this socket, but nothing really beyond 8 cores. That said, for gaming and the absolute maximum frame rates in gaming, there's not a lot of difference between 4 cores and 6 cores because, as I said, games are really optimized for 4 cores. And so gaming plus a little bit of breathing room to do something in the background, that's who this platform is for. People that are running SLI, 1080s, that's gonna work really well on this platform. Audio production people, like the secondary uses of this system that I described for low latency, I think that'll work pretty well. But if I've missed anything or made any horrible mistakes or you just want to make fun of me, that's cool. People do that. It's in the level 1 forums that you could come and hang out and, have a community or something. We're going to do a UEFI tour right after this, but I'm Wendell, I'm signing out, and I'll see you later. Maybe. Well, probably. I don't know. UEFI tour time.